This puzzle is called 15 Sums by DJV. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. The only rule for this puzzle is X sums. So a clue outside the grid indicates the sum of the first X digits in that direction, where X is the first digit in next to the clue in that row or column. So that sounds a little bit complicated, but it's actually very simple. So some number of digits along here are going to add up to 19, and the number is given by whatever the first digit is. So that means if this is a 4, that means the first 4 digits are going to add up to 19. If it's a 3, then the first 3 digits. If it's a 6, then the first 6 digits, and so on. But yeah, it's not too complicated. Um, yeah, I don't know how hard this puzzle is. Let me check the post again. Didn't think it said anything. Oh, I don't have it up anymore. I don't think it said anything about difficulty. You'll have to judge by the length of the video, I guess. I'll put a link to the puzzle down in the description if you want to give it a try yourself. Let's get going. So, there's a few places we could start. Like, the 6 can only be could be a 2 or a 3. If it's a 2, then this is going to be a 4. If it's a 3, then this needs to be a 1, 2, 3 triple, or a 1, 2 pair with a 3 there. And 8 is also 2 or 3. And 9 is 2 or 3. So we actually have a little bit of a thing going on here. Wait, maybe I'm confusing myself. Are these not 2 or 3? Couldn't be 1. It couldn't be 4. It must be 2 or 3. Oh! I can't do math in my head. That's the problem. I added this 20 plus 34, I added them together in my head and got 44, which is a very not right number. So the way that this puzzle, or that this row is going to be arranged, is going to be some number of digits from the left. Let's say this. I don't know if that's true or not. Let's just say it is. And then some number of digits from the right. Now, because we add up 20 and 34 and we get 54 and not, whatever I said, 44, that means that we have an overlap of 9 digits, which means at least one cell is overlapped. So it could be like this. Actually, I probably shouldn't use green and pink together. Let's use pink and blue. Those are probably hopefully different. If you have any like color blindness preferences, whether or not you can see it clearly or not at all or whatever, feel free to let me know. I just kind of choose whatever colors look pretty to me because I mean there's nothing else to base it on. So let me know if it's actually hard for you to see the colors. Anyway, so in this case, and now this is not necessarily the case at all, but if this was the case, that would mean that the overlap would add up to 9 because, oh, I skipped a step here, but the overlap adds up to 9 because this adds up to 54. Now, how did I get that this is 9 then? Well, the full row is going to add up to 45. If you take any box, row, or column, it contains the digits 1 to 9 exactly once each. If you add up the digits 1 to 9, you get 45. So that means the sum of any box, any row, any column is going to be 45. So the fact that these two sections add up to 54 means we must have an overlap of 9. Yeah, so we have a bit of an overlap. We don't know exactly how they'll go. So let's delete some of this middle bit. Let's think about what this digit could be. So theoretically, this could be a 3 if this was 8, 9. If this was 8, 9, this could be a 3. But this can't be an 8 or 9. And in fact, this can't be a 3 either because you have a 2, 3 pair. So that doesn't matter. So this is at least a 4. It could be 5. Could it be a 6? No, it couldn't be a 6. So if the minimum, let's just say up here, we had 1, 2, 3, 4, 5, 6 as all in a row, that would add up to 21. You can just add up the digits very easily. So in order to get 20, we can't have it go this far. We can't have it go over to the 6th digit because, of course, that would be 21 minimum, and it needs to just add to 20. So this is going to reach here, but it could reach to here. And I'll just do actually, yeah, I'll do gray for, we don't know if it's there or not. But it's, oh wait, no, I did that too many. Sorry. I can't count to 6 4 is definitely in there. 5, the fifth one could be in there. And if this is 5, this is going to be a 2-3 pair still, obviously. So that would be 10. So these two would add to 10. If this is a 4, these two add to 14 or so 13 or 14. And both of those seem perfectly reasonable. Okay, now for the 34 side. Gonna need a minimum of 5 digits. But actually, wait, does 5 work? Can you have a 5 and a 34? So theoretically, theoretically, if you're just adding up digits to get to 34, it would be 4, 6, 7, 8, 9 in 5 digits. To get to 34 in 5 digits, I don't think that there's a way to actually get to 34 in 5 digits with a 5. Let me actually just look that up. I can't think of a way, but this is the first puzzle of the day, so it might be kind of stupid. No, there is not another way. So we can't actually have it be 5. It could be 6. It can't be 5, so it could be 6. Now, how many digits are possible? So there's going to be 11, a total of 11 sum. They're like a sum of 11 digits, or no, that's wrong. Sum of digits equal to 11 that are not included in pink. So that could be this much, or it could be this much, basically. So that would be, what is that, 6 or 7? Yeah, we could do like 5. Well, let me do math in my head real quick. That's hard. Like, oh my gosh, why is it so hard to come up with digits that add up to, so this was 5, this was a 2, that would be 7, and then, yeah, 5, this could be 5, 2, 4. That would add up to 11, this would be a 3. And then this would be all that we need. Or it could be 5 and 6, and this would be, and we could come all the way over to here. Actually, it couldn't be, yeah, it could be 5 and 6 like that, something like that. Now there might be some particulars that I got wrong there, but the overall idea, whoops, is correct. So 6, 7. We know at least this much is pink. It could be here as well. We know this is pink. Yeah, this... Can we change this to dark blue, maybe? I don't know if I like that or not. The dark blue is pretty dark, but I don't really like the light blue either. Maybe we do this. Is that okay? Or this. That's pretty different. That's pretty different. Okay. Hopefully that's still visible. I just did not like that blue and that pink next to each other for whatever reason this morning. So if this was 6, that would mean that these add up to 11, which means for the 20 clue we would need 9 more, which could mean just a 9 here, or all 3 of these would be 9. Sorry, just these 2 would be 9. If this is 7, this would be... If this is 7, this has to be 5, 6. Which means this has to be a 4. Right, this is actually pretty forcing. I don't know if there's anything we can, figure out about it, but if this is a 7, the only way to make this add up to 11 would be 5, 6, because we couldn't use 4 because it would match up with the 7 again. So 7 here makes this be a 5 in order to make these two add up to 11. Now we have 5 here, which means for the 20 clue, this would have to be a 4. That does force like every single digit along here, but it doesn't quite... Which forces this to be a 3, and this to be a 2, this to be a 7, this to be a 1. Yeah, it forces so much stuff, but it does not actually, like, break anything. Okay, what about... Let's look at a different row, I guess. Yeah, let's look at this row. So we have a 31, which is a minimum of 5 digits. If you just add up 4 digits, you have 6, 7, 8, and 9 as the maximum. That only adds up to 30. So 31 needs at least 5 digits. But you could make that in 7 digits, actually, if you had 14 left off. So up to 7 digits, okay. And then on this side, we have 10, which is, let's say, 2, 3, 4. Yeah, 4 is kind of the opposite way. It could be 1, 2, 3, 4, and that adds up to 10. 30 being the maximum of 4 digits and 10 being the minimum for 4 digits is what I meant by that. So we're going to have some amount of digits coming from this side. We don't know about those two, and we're going to have some amount of digits at least here. Let me do... Maybe I do blue and green. Sorry, green and yellow. I cannot speak this morning. Jeez Louise. Okay, so we have at least 5 here and at least 2 on this side. And then these are kind of up in the air. Now, when we kind of look at the row as a whole, we have a 31 on this side, a 10 on this side. That's going to leave a sum of 4 unshaded in the middle. So we have to have some amount unshaded. Which means yellow... No, could yellow reach here? Yellow couldn't reach here because then at the minimum, this would be 5, and we would run out. We would run out of room. And then on this side, this couldn't be a 7. Sorry, 1 second, I forgot to mark that out. If this was a 7, then it would butt up right against the minimum on this side. So this can't be a 7. So this can't be a yellow. So now we have kind of like the space in between. Could we have both of them not be in? So again, we have 31 plus 10 is 41, so we have 4 unshaded, some of 4 unshaded, so it could be 1, 3, theoretically. Then we'd have a 2 over here and an 8 over here, and then the rest of the stuff would just add up to the correct amount. Yeah, that works, I think. Okay. But it could also be that it's just the number 4 is in one of these cells and unshaded. I think, at least. I don't see why that would break. But, yeah. What about 35? That's a pretty big number. That's, in fact, a minimum of 5. But it would require 5, 6, 7, 8, 9. Whoops, it would require 5, 6, 7, 8, 9 for this much. But we need 10, so this is a 5, 6, or 7. It would need 10 unshaded on the other side. We don't know anything about this side. Oh, we do know about here. I didn't see that, so I'll look there next. So it's either here, here, or here. And I don't think this 5, 6, 7 interferes in any large way. I was thinking it might interfere with these other digits. But doesn't quite. Like, if this only could be 5 or 6, maybe we could do something with that, but I don't see it. Okay, so let's look at this column. I didn't see this earlier. So this is 2 or 3 here. So let's do dark or light blue, I guess. As much as I didn't end up liking that light blue. 37 down is going to be at least 6 digits. And theoretically up to 8 digits, because we could just have a digit... Well, for multiple reasons this doesn't work, but theoretically we could have 8 digits here add up to 37 and then have 1 digit not, like, be the extra of the 45, which would be another 8. Which of course we can't have 2 8s in the column, and also we already know this digit can't be a 2 or... Sorry, is a 2 or a 3, can't be an 8. So this is 6 or 7. What if we add these numbers up? Let me do pink, and then there's maybe a pink there. So 37 plus 9 is 46, which means there's a 1 that's going to be overlapped. So we're not going to have any empty space, and we're going to have a 1 overlapped, which means this must be the overlap, right? This must be overlapped, because it's the only cell that can be overlapped. Because this can't be an 8, like you would normally think it could be, it's actually pretty restricted. This is a 7, this is a 1, this is a 3, which makes this a 5, and this a 2. And this can't be a 5. This must be 7, this must be 3, because we need an overlap of a single cell, and there was only one possible overlap cell. Yeah, I think that's right. I'm going to take out this coloring because we're basically done with this. And we have 8 sticking out on this side, so that's another check. We're basically done with these two. I mean, we can put whatever digits in here. I mean, the remaining digits are going to work out no matter how we put them in. We now have a 6, 7 pair here, which is a little nice. Does that mean anything? Oh, this must be, if this is a 2, this must be a 6, so the 8's done as well. I say this whenever I do an XSum puzzle. I wish you could, like, gray out clues on the outside, because obviously we finished these clues, so I don't need to look at them anymore. Okay, let me think a bit. Maybe this 25 and 25. Generally with X sums, at least in my experience, you either need to look at very restricted numbers, like the 8, 9s, and the 6s, or like very large numbers like 37, or look at the overlap, like I've been doing with these rows. And it turned out in this case it was a kind of a combination of both. Of two very restricted digits, or two very restricted clues in the same column was where I should have looked to begin with, but I just didn't notice that this 37 matched up with this 9. Okay, so to get to 25, you need at least 4 digits. If you add up 3 digits, the most you can get to is 24 with 987. So we need at least 4 digits. Whoops. Oh, we could have 5, we could have 6. And I think that's it, because we need the remaining digits to add up to 20. So you need at least 3 digits to add up to 20, so this could be up to a 6, and the same is going to be true for the other 25. Now, kind of the weirdness about this, because they're both the same, it's gonna be weird, I think, because the overlap, if we add 25 plus 25, that's gonna be 50. The full row adds to 45. That means we're gonna have 5 left over. So if we we tried to make everything 5s, it would sort of work out, except for the fact that there's 3 5s in the row, which is not good. So we have an overlap of 5. What does that mean? If we did 4 and 6, that would leave one cell overlapped as 5, as the digit 5. If we did like 5 and 6, that would leave 2 cells overlapped, and it would be a 1-4 pair, because we can't do 2, 3. Well, I'm trying to think about how this 6th clue interacts with that. This is a 2, this is a 4, which means this must be the number 5, the digit 5, in a 4-6, like overlapping like this, or the opposite side, like this. So a 5 would go here or here. If this was a 2, this would be a 4, and then we would have the 5 like that. If this is a 3, this is now going to be a 3 and then a 1, 2, which means this can't be a 5 any longer, but it could be a part of the 1, 4 that I talked about. And in fact, oh no, it doesn't have to be like that. It could be, if this is a 3, this could be a 2, 1, and then have this extend over here and still have a 5. Yeah, that does too many options to really think about, something being broken there. I do see that we have a 4, 5, 6 triple along here. So maybe this is where we need to look. And I'll just use light green for this, I guess. So 19 needs at least 3 cells. If you add up just 2 numbers, 8 and 9, that's 17, so you need at least 3 digits. But now we have this 4, 5, 6 triple, so it can't be any higher. This just must be a 3. Okay, and now we need this to add up to 16, so this must be a 7 and a 9. Okay, that one's just done. Okay, that was easy. Because one of these is a 7 now, because we have these 7s. This is a 5. This must be 1, 9. Wait, what? 1 second, let me think about this. If this is a 5, that means these 5 add up to 20, which means these 2 need to add up to 10, because we already have 5 plus 2 plus 3 to be 10. So the other 10 must be in these 2 cells. It can't be 2, 8, it can't be 3, 7, it can't be 4, 6, because we have all of those already claimed. So it must be 1, 9. So how do we make this 34 clue work? If this is 1, 9, there's no way we can leave just 11 off the other end. That I'm seeing, at least. Because if we go here, this is either 6 or 14. If we go here, this is either 8 or 16, and if we go here, this is 17. So this can't be a 5. This must be a 4, this can't be a 4. So now this is not green. We still don't know about this side. And oh, no, we do know about this. If this is a 7, that means the outer bits, the non-yellow bits need to add up to 11. Which means this would have to be 4 plus 7, and this 7 doesn't work. So this must be 6, this must be 7. Which means this is not an overlap. Sorry, yeah, it's not an overlap. I said that correctly, actually. Okay, which means this must just be a 9, right? 20 plus 34 is 54. That's 54 minus 45 is 9. Yeah, the overlap must sum to 9. Now this needs to sum, the just greens need to sum to 11, which is 6. This needs to be a 5. And then what's left is 1 and 8. Yeah, and there's a 1 over here somewhere. There's a 6 up here somewhere. And a 5 up here, but I don't really need to mark that. This can't be a 6 any longer. Does it? Okay, I think this row is done. Let's just focus on this row. I think this row is done. I don't think we can eke out any more information about this. So let's just delete those colors so we don't get too overwhelmed. But the options up here we must have at least 1 6, which must be green. Because if we don't have a 6, this is 5, and then we can only have an overlap of 5 and 5, which puts a 5 here, which would break so many 5s. So many 5s would be broken at this point. So it can't be 5 and 5. We must have a 6 in order to have the overlap. So this must be a 6, this must be a 5. Which means this can't be green. Which means it's unshaded. So this 6 comes over here. We still don't know. This could be just a 5. No, if this was a 4, then yellow only comes to here and the overlap sums to 5, so this would be a 5. Or this is a 5 and we have this full overlap, which needs to still add to 5, which has to be 1 4 because it cannot be 2 3 over here, which would have to be like that. So this is either, so I guess in either case there's a 4 and, no, wait. No, if this is 4, this is 5. If this is 5, this is 4 1. Yeah, never mind. For some reason I was thinking in both cases there was a 4 here, which wouldn't make sense because I literally said there was a 4 over here in one of the cases. Okay. So I don't know if writing that in is helpful since it's not like all the options, it's just some of the options. And I think this could still be 3 2 1 or 3 1 2 because we don't have to have we don't have to use the 1. It would certainly be restrictive, but I don't think it's a requirement. Okay. What about this row? We now know this is a 5. So this is, I guess this is a 1 3 or a 4. Because either it's the only non-overlapped or underlapped, I think that's a good term for it. This is either the underlapped digit, the non-shaded cell, in which case it must be a 4. Or these are both unshaded, in which case it must be a 1 3 pair. And I think that works. Okay, I think we're good there. So which ones have we done? We've done these. Can we do anything with this 7? These two add to 10? Maybe I will shade this. Let's go with pink. So this adds to 10, which still has a bunch of options because for whatever reason we've mostly used 3s and 7s around the grid. Yeah, I don't think that's quite helpful, but I do want to remember that I haven't done it yet, so let's just keep that around. 19 is done, 16. Theoretically, we could add a 2 digits up to be 16, but once we include a 2 in that, we can't do 2 plus anything to equal 16. So this is at least 3, and at most a 5. If we try to add up 6 digits, we talked about this at the beginning, if we add up 6 digits, that's going to add up to 21 at a minimum. So we can't do that. And actually we have a 3 and a 5 looking right at this cell, so this just must be a 4. Let's color that in. So we have 4. If this is a 9, that's 13. This would have to be a 1 and a 2. If this is a 7, this has to add to 5, which has to be a 2 and a 3. Because wait, if this is a 4, this is a 7, which means these need to add to 5, which means it must be 2, 3 because we've already used the 4. Right, so this is either 1, 2 or 2, 3. And this, whoops, this can't be a 3. But one of these is a 2. Okay, that's interesting, I think. It's at least some digits in there. Okay, we haven't done the 6 yet either. Maybe we can highlight that. This is a 2, this is a 4, which still works. This is a 3, this is a 1, 2 pair, which still works. Okay, that's unfortunate. We've done the 37. Now we need a 12. So 12 could be 3, 4, 3 or 4. If we add up 5 digits, that's going to be a minimum of 15. And we can't do 2 because 2 plus whatever would need to be 2 plus 10 to add up to 12. Oh, and this can't be a 4. There's literally a 4 right there, so this is just a 3. Okay, so these 3 digits add up to 12. But more importantly, this is now a 2, because we just put a 3 right here. So this is a 2, 4. Now the 6 is done. And that 4 does put a 4 along here. Oh, that is important. That is very important. So we said in row 3 that if these overlap, or these will overlap, they're either overlapped in one cell, which is a 5, or 2 cells, which had to be a 1, 4. And it can't be a 1, 4 because it also can't be a 2, 3. So this only overlaps in one cell. So we know that one cell is here. This must be a 5. Which means it must be a 4. I guess we didn't need to rule that out. Once we knew that there were only 4 digits there, we didn't need that. Okay, so we have a 5, a 4, and a 7. What's the other digit? That's 9. That's 16. That must be a 9. 16, 20, 25. Yeah. And then one of these two is a 2, I guess. I'm just seeing based on the fact that 2 can't go in here. Oh, and this can't be a 2. There's a 2 right there. So this is just the 2. Okay, so that helps a little bit for this clue, but not fully. What's left in this row? We need a 1, an 8, and a 3. This can't be a 3. Oh, this can't be a 1 or a 3. That's gonna fix a lot of things. Okay. So now we're just done with this row. We don't need greens anymore up here. We don't need yellows anymore. No matter how we put these 7s and 9s in, they're going to be 7 and 9, so that's fine. Okay, what about this 12 clue? This one's done, yeah. So 12, we have a 3, so these two need to add up to 9. Well, we can't have a 9 in the sum of 2 digits that add up to 9. So this must be like this, and then we need a 2 here to make this add up to 12. So we're good there. What? I think my phone just buzzed. I'm going to ignore it for the moment. What's left in this row is an 8 and a 5. And there's a 5 right there. So there's this the 5 and that's an 8. Okay. These two add up to 10. If you remember because this column in full adds up to 35. Sorry, adds up to 45. The pink adds up to 35. So the leftovers is 10 or 10. 1, 9 works, 2, 8 doesn't work, 3, 7 doesn't work, 4, 6. So this must be 1, 9. This 7, 9 parallel is looking over, so this is 1, 9 like this. And we finish the box. So this is done. This can't be a 1 anymore, but this is done. However we put the digits in to the remaining cells in this column, it's going to add up to the correct amount. So what's left here is a 5 and an 8, which we don't have a handy 5 down here, unfortunately. And a 1 and a 6. We do have a handy 6, though. Okay. Okay. So we still have the 16 left. We've done this one, we've done this one, we've done this one. We have not even looked at the 27 clue yet. Let's at least get some colors in here. So this is either, this would need at least 4. It needs 18 digits. Sorry, a sum of 18 digits on the left side here, not colored. So at most 6. Yeah, we need 18, so it could be, there's a couple ways to do 18, of course, but so we have at least this many. Let's make this light blue. Actually, light blue and gray don't look good together. Let's just do pink again. So 4, and then one of these could be in there. Okay. Is there anything more we can do with this guy? I don't see it. Okay, let's, probably Sudoku is gonna be the answer. And yeah, I immediately see that Sudoku is the answer. Okay, so what's left in this column is 2, 4, and 9. Which means this cannot be a 4 because we already guaranteed that a 4 is in this column. So this is a 3, which means this is a 2. And now we have this arranged, and we're going to start getting some information. The unshaded has to add up to 4, if you recall. So this must be like this, and the yellow needs to add up to 10. So we've finished yellow. We finished this whole row, in fact. Let's change this to green just so we have, if I just say pink, you know exactly what I'm talking about. And let's actually change this to yellow. I've been liking the yellow color more and more lately. And this actually can't be a 4 or a 6, so this is just 5. I probably could have done that when I just filled it in to begin with, but I missed it, so what can you do? This is a 5 just by Sudoku. We've filled in a bunch of 5s all around the grid. This 5 looks up and makes it like that. And then this is the last 5, I think. Okay. So this adds up to 18. That's not super helpful. This adds up to 27. That's also not super helpful. There's a lot of ways of making 27 in 5 digits. Okay, so 4's, let's look at this cell. So we need a 1, we need a 2. So 2 is over here, and 4 is over here. Because we have a 2 and a 4 looking down into this box. None of these are 2 or 4. These two must be 2 or 4. Means this must be the 6, and this must be an 8. What's left in this column is 1 and 7. This 1 situates those. There's an 8 and a 6 left. We're good there. Okay. Yeah, I want to finish off this silly pink clue. Not quite. Let's just do some more Sudoku. For this column, we need a 3, a 7, and a 9, which we don't get any information about. Okay, what about this column? We need a 4, 6, and 9. This can't be a 6. So there's a 6 up here. So that actually gives us something. So let me delete the colors for a second. So in rows 4 and 5, we have a 6 locked in here and a 6 locked in here. How many 6s are there going to be in these 2 rows once we finish the grid? That is a bit of a trick question. There's going to be exactly 1 6 per row, so in 2 rows we're going to have exactly 2 6s. Well, we've already claimed one of these 2 6s in pink and one of the 2 6s in yellow, which means the other 6 must go in, the other 6, sorry, the 6 4 box 4 cannot go in either of those rows, which puts it down here. And there was a better way to look at that. We could just say, what's the remaining cells for this, or the remaining digits for this row? It's just 4, 6, 9. That's probably the best way of looking at it. And this 6 figures that out. But there are multiple ways of solving almost any problem in Sudoku, and it's good to be on the lookout for different ways to do that. Okay, so this adds up to 17. There's a lot of ways to make 17 in 3 digits. Okay, let's just keep looking at Sudoku, I guess. Am I missing anything? Am I missing anything? Not that I see. But how would I know? Because I'm missing it. Okay, 8 goes in one of these 2 cells. One is in one of these 2 cells. Maybe there's less options here than I'm thinking. Let's just do a little bit more Sudoku. Maybe we can figure out something in a second. So this needs a 1, a 2, which must go down here. A 3, which can go in any of the cells. A 4, which can go in any of the cells. 5, 6, and a 7, which can go in any of the cells. Well, that's not great. Okay. let's look at the combinations, I guess. Maybe this is more restricted than I think, although it definitely does not seem that restricted. So let me just turn on Notepad view here. Okay. And make the text a little bit bigger because it loves making the text as small as possible whenever I open up Notepad. So these are the options for 18 in 4 cells, which would be these cells right along here. Maybe we should be looking at 27 and 5. I don't know. Which it must have a 1, so that can eliminate a lot of these options, and it can't have a 5, which does remove. So we have a couple options, and it can't have a 6. That's also another thing because of this 6. It can't have a 6. Oh, which leaves literally one option, right? Did I delete the wrong thing? No. So this should just be 1, 2, 7, 8. What did I press there? I don't know. I pressed one of the F buttons and it popped up. I don't know if you saw the pop-up, but it was like, do you want something weird that I've never heard of? And no, I don't. I like stuff that I've heard of. So this is a 278. This is 6, this is an 8. This is 6, this is not a 6. Whoops, not a 6, I said. Not. Okay, there we go. 278 means this is not a 2. Puts the 2 there. 278. This is not a 7. And it's not a 4 because of the 4-9 pair, so that's just a 3. Removes a couple 3s from around the grid. And now yellow's done. One of these is a 7. I don't know how helpful that coloring is. Yeah, the 27 is done, though. This can't be a 2, this can't be a 2, based on the 2's looking in, so this is the 2. Where do we put the 7 in column 1? We can't put it here or any of the filled in cells, so it's down here. Okay, oh, 4, no, 4 is in one of these 2 spots. I thought it was going to be placed up here, but no. Not quite. Is there a clue we haven't done? It feels like we need a little bit more to finish this off. It'd be pretty amazing if just this finished it off. 20 plus an 8 plus an, or 28, 9, 35 we did, 34 we did, 10. Yeah, that one's done as well. 27 is done. Let me just double check this. So this is 4 plus 6 is 10, plus 9 is 19, plus 3 is 22, plus 5 is 27, yeah. 25 is done. It's 12 plus 13, yeah. 12 is done, 37 is done, 6 is done. Not done, but yeah, that definitely seems like that's the last one. Okay. Well, count me pretty amazed that that's all that's required. So what's left in this column is 1, 7, and 9. This can't be a 1. And this can't be a 7. Because I don't need to mark that anymore. This is... I guess 3 is in one of these 2 cells. 3 is up here. So this is... Can't be a 1. Can't be a 2. Could be a 3, 4, 5, 6, 7, 8. Could be a 9 as well. That's a lot of options. So the options up here, these two need to add to 10. So this is either 1, 9 or 7, 3. This is 7, then this is 7 if this is 9. This is 9, 1, this is a 1, we'll have a 9 along here. Okay, let me just keep filling out these cells, I guess, because I'm missing something. This could be a 1, can't be a 2, could be a 3, 4, 5, 6, can't be a 7, because 7's over here, can't be an 8. So this is just 1, 3, or 9, actually. So 3 is in one of these 2 cells. Because if this is a 7, 3, this is a 3, obviously. And if this is a 1, 9, then this is a 3. So this can't actually be a 3. So one of these is a 3. I'm going to put that 7 pencil marking back. So this can't be a 1, 2, can't be a 3 by what we just said. Can't be a 4, can't be a 5, 6, can't be a 7, so this is an 8 or a 9. Oh. Okay, that's gonna help a little bit. Let me fill out this cell. This is the last cell here. So it can't be 1, 2, be 3, can't be 4, 5, 6, can't be 7, could be 8, could be 9. Now, in this column, oh, I guess the easiest way, this is a 7, 8, 9 triple. So this can't be a 9, which means, let me just get rid of some of this pencil marking. Actually, now that I keep taking it out and putting it back in, let's take it out one more time. This is a 1-3 pair. Yeah. So either this is a 1 or this is a 1. Same with 3s. I feel like I'm missing a clue here because this doesn't seem like this resolves easily at the end. Did I forget to remove some options over here, maybe? No? I just see there's a lot of 4-9s around the grid. Let's just highlight those. So, if this is the yellow 4-9, then these are going to be the opposite of it. So this is a 4. If yellow is 4, then greens are going to be 9. Similarly, if yellow is 9, greens are going to be 4. So this is yellow, so this is green. So green is going to be up here somewhere, in one of these two cells. That doesn't really say anything that I see. I was thinking like there might be a sneaky, like this, where's this? There's not even a really good example of it. But if, let's say this turned out to be yellow, then this cell couldn't be either of them because it sees a yellow and it sees a green. Now, as it turns out, all the yellows and greens are kind of locked up in the same rows or columns, so we could have figured that out probably anyway, but that's what I was looking for, was some sneaky, like, oh, this cell actually sees a yellow and a green, so that means it can't be a 4 or a 9. But I don't see that that's the case right away. Okay, so what... there must be something silly I'm missing here, I think. Okay, so 19 was done. 25 is done. 31 is done. Double check the math there. That's 12 plus 10 plus 9 is 22 plus 9 is 31, yeah. 11 plus 9, that's 8, that's 9. That's, we had 10 left over, so that's 35. Whoops. This needs 11 on the outside. Oh, that is 11. Okay, for a second I panicked. 4 plus 9, sorry, 4 plus 5 is 9, plus 2 is 11. This is 8. This is 27, but it has both green and yellow, so we don't know which is which. Same with the 31, it has both of them. But that's 13 in green and yellow, plus 9 is 22, plus 5 is 27. 11 plus 14 is 25. 10 plus 2 is 12. We have 37 here, but again, it has both green and yellow. These add up to 10. There must be something here. If this is like, let's say 1, 9, then this is an 8, 3, which makes this a 9, 7, 1. If this is 9, 1, this is 8, 3, makes this a 9, makes this a 7, makes this a 1. What if this is 7, 3, this is a 1, this is a 1, this is 7, 3, this is a 1, 9? Oh, that breaks it. Let me look at this again. So if this is 7, 3, Then this is 8, this is 9, this is 1. And now we've broken the puzzle. I don't see an easier way to do that, because the restriction here is that we're taking up 2 spots for 3 and 8. 3 and 8 both must go in this cell. Or another way to look at it, we don't have enough digits to fill those 2 cells. Yeah, that's the trick at the end. That was a tough spot. I mean, there was only one clue left, so there wasn't that many places to look, but it definitely, like, obviously there's Sudoku. That was a tough spot at the end. Let's go back. So if this is 7, this is 3. That makes this an 8, that makes this a 9, that makes this a 1. And we needed to place one of 3 or 8 in one of these 2 cells, because they were both restricted to one of these 2 cells and this. Yeah, that was tough. So it can't be 3, 7. It must be 9, 1, which is gonna then just resolve the rest of the grid. And my coloring here was totally useless, but that's okay. You gotta try to find anything, basically. Um, let's just get rid of the colors. If you're a little lost, just, you gotta just keep looking. See what you can see. This is a 3, this is a 3, 9, this is a 1. This is a 3, this is a 9, 8, 7. There we go. Yeah, that was probably like a 3 out of 5, I think. Maybe a 2.5 out of 5. But that last step I did think was pretty hard to spot. Yeah, so 2.5 to 3 out of 5 probably. But that was a lot of fun. I wasn't a really huge fan of that last step, but besides that, I really enjoyed the puzzle the whole way through. 95% of the way through, I really enjoyed that puzzle. Um, yeah, that was a bit of a chain to finish it off. But other than that, it was great. So thank you, DJV, for that puzzle, and thank you all for watching.